Thank you for coming. Oh, I forgot to make start screen. Oh, I forgot to do that. Talk too much before that. All right, so we will do comparison test. Oh, I should have showed this one earlier so that you can write down, right? So 5.4, we're doing comparison test. So we have a theorem. I want to use a theorem directly, comparison test. So look, we have a sub n is greater or equal to a sub n. And this a sub n is greater or equal to 0, right? Look, we said b sub n is bigger than a sub n, okay? Look, we have a series, summation, we have a series. Then b sub n converges, then the series of a sub n converges, okay? This comparison test, and then your homework and other textbook use that direct or basic in your homework, right? So basic, let me write down, where is it? Direct comparison test or just a comparison test, direct basic comparison test, right? So everything's the same. All right, then second part, I did not follow the book way because a little bit confusing. So look, we got a same order, which is b sub n is greater than a sub n, okay? Then the series is the diverges of the a sub n, right? Then the series of b sub n diverges as well, okay? This is how I remember. The bigger series converges, then smaller series also converges, okay? If the smaller one diverges, yeah, even if we say the smaller series is diverges, then bigger series is also diverges. Is it kind of make sense? Okay. Smaller series is we show that that's converges. Then bigger series is converges automatically. We can conclude. Okay. Then smaller series, we show the diverges. Since a smaller series diverges, then bigger series is diverges. Make sense?
What do you mean by like bigger or smaller? Just like a bigger or smaller?
Yeah, because look the inequality, right?
Oh yeah, okay.
Yeah, so this is bigger than this one or equal to, right? So let us do an example so that we understand which one is bigger, which one is smaller, okay? All right, so we're gonna set it up by given information. So look, we have determine whether the series converges or diverges. Okay, so we have a series from n into a, did not write down. 1 n to the third, we cannot say that. n to the third power plus 3n plus 1, okay? Look, we're gonna set it up. We say this is a sub n. Let's say that. We're gonna set it up b sub n. Look, b sub n, 1 over n to the third power. I'm gonna set it up this way, okay? Why? Because this one greater or greater than or equal to. Can you see that? Okay, think about this. The denominator is bigger, right? Denominator is smaller. That means the fraction is bigger. Yeah. For example, let's say that 1/9 is smaller than 1/2. Make sense? Okay, now we're gonna show that, okay? We show that, let me think. The bigger one converges, show that bigger one converges, then the smaller one also converges, right? So we're gonna show that B sub n is converges, right? So how can you say that? How can you say that this one is converges? Or we can show that this is diverges, right? Does anyone click something? 1/n cube?
Is it a p-test?
It's a p-test, good.
So it converges?
Very good. So it's a convergence. P-series. P-test, P-series. P-test, P-series.
I can't remember either.
P-series. P-series. P equal to greater than 3, which is great. I'm sorry, P equal to 3, which is greater than 1, right? Yeah. Then we can conclude that, right? So we can conclude the sequence. So let me write down the series from 1 to infinity, right? Okay. Now we can say the series B sub n is convergent or converges. So A sub n is also convergent by comparison test. Okay, so we have to say by what? All right. So you guys understand which one is bigger, which one is smaller, right? Okay, let us do second part. We have 1 equal to infinity. And we have 1/2 to the n plus 1. Okay, this is A sub n. And I want to set it up B sub n. Which one is very similar? Set it up B sub n. Looks like this one. What do you want to set it up? But we want to B sub n is greater over this one. Can you see that? We have more terms in the bottom. So we take out everything and then we make this one. And how about this one? Same pattern, same concept. B sub n. So this will be B sub n. Good. Okay. Now, how do we say 1/2 to the n power?
The geometric series?
Very good. It's a geometric series because we can express this one as 1/2 to the n power. It's the same, right? So is it converging or diverges?
Converges.
Converges. Why?
Approach.
Geometry
1/3 is less than
space.
1.
Good. R equal to 1/2 is less than 1. Okay. So it's a converges. Very good. Okay. So since the B sub n is a converges, then we can conclude the A sub n converges by comparison test. Okay. Oops. Let's just make it this way. So then converges. So A sub n converges as well. By comparison test. Okay. How about this? So we have n start to 2 to the infinity. We have 1 over ln n. Okay, a little bit different. Okay, so this one, say this is A sub n. Now B sub n, we're gonna say that 1 over n. Okay, when ln n equal to 2, 1 over ln 2, can you please compare with that 1 over 2? What is ln 1 over ln 2? Can you please calculate 1 over ln 2? Okay, no one calculate?
I'm calculating.
1.44.
1.44. Okay, so what about 1 over 2? 1 over 2 is 0.5, right? So basically 1 over ln n is bigger, isn't it?
1.4427.
Yeah, so we're gonna set it up this way then. How about that? So this is B sub n. This is A sub n, right? Okay. Look. Same concept. We can show that this one is diverging, or we can show this is converges, right? So what can you say? What can you say that? By comparison test, we said that smaller one.
Just it's converges.
Converges, then we show that this is converges, right? Bigger one converges, then small one is converges as well. If this is diverges, then this is diverges as well, right?
Yes.
Okay, so this is converges. Why?
Because it's bigger.
We have to say, can you see that? Converges by what? Now we cannot say the bigger. There is what? Converges what? We have to say some test. Why this is converges, right? Okay, then if you cannot think, I'm gonna say this is diverges. Why?
The comparison test.
Diverges. It diverges. Why? Does anyone notice this one? Harmonic series. Yeah. Okay. So we know that this diverges by harmonic series, right? And also we can say that by P series, P equal to 1, right? P series. P equal to 1, less than or equal to 1, right? Okay. All right. Now, since the smaller one is diverges, even though smaller series is diverges, right? So that the bigger one is diverges, bigger series is diverges, right? So therefore, A sub n A sub n diverges. So B sub n diverges by comparison test. Okay, confusing a little bit, right? So comparison test, direct comparison test, or basic comparison test. So we compare with very similar one with a given information, right? So we make a bigger one or a smaller one like that, okay? So we do like this. Make sense? Okay, now limit comparison test. So limit comparison test, I will bring here. So look, limit comparison test. Okay, in this case, there is no inequality about the A sub n, B sub n, right? As long as positive or equal to 0 for the A sub n, B sub n, I'm talking about this, all right? Then look, limit comparison test set up. So A sub n or B sub n will be given, then we create like a B sub n or A sub n as earlier, okay? Now we take the limit, then we divide by B sub n, okay? So we have A sub n divided by B sub n. We get some number. Any number is not equal to 0, okay? Then we can say that, so like earlier, B sub n, we can conclude, oh, this is by converges by geometric series. Oh, diverges by divergence test, like that. Converges by integral test. We don't have that because of limit, right? So we take the limit, yeah. We notice that converges or diverges, okay? Then it's not equal to 0. Then we conclude, oh, B sub n converges, so does A sub n converges. B sub n diverges, so does A sub n diverges, like that, okay? All right, so in this case, second one, we take the limit, we create same B sub n or A sub n. Now we divide, okay? Then we simplify. Then we apply the limit when approach to infinity. Then we get 0. Then same concept. The series of B sub n converges. Then the series of A sub n converges as well. Okay. This one, if we get the positive infinity, then B sub n series of B sub n diverges. Then series of A sub n diverges. Okay, so there's a 3 types. One is number, one is 0, one is infinity. Yeah, it's hard to remember, right? So I think you don't have to remember, just to know how to apply, right? Because it's hard to remember. Okay. But other series we must remember, right? Okay. Right beside the comparison test, direct comparison test is hard to remember too. Just know how to apply. But geometry series, divergence test, integral test, P series, harmonic series, telescoping series, you should remember, right? Partial sum, like that. Okay. Let us do this one. We have determine whether the series converges or diverges. Okay, so we have the first one. We're gonna have a 2. One over square root of n plus 1. Okay, so which one you think very similar with this one? B sub n. We create B sub n.
Like what series?
Yes.
What's number?
We could do a P series because
No, B sub n. We can create a B sub n.
Can we use a P series because square root of n is less than 1?
Okay, we have to create one series, very similar with A sub n. Like this one, can you see that? We created this one earlier, right? We create B sub n, this one earlier. Can you see that? From here to here. And we create from this one to this one. Yes?
Oh, I see. Okay, I'm getting ahead. Okay. It's just 1 over square root of n.
Very good. So we're gonna say that. Good.
Get rid of the 1. Forget it.
Yes. Okay, we're gonna say that. All right. That's a B sub n. It does not have to be greater than A sub n, right? Because they say so here, as long as it's positive. Okay, good. Now, we're gonna divide, take the limit and divide A sub n by B sub n, okay? So we take the limit. This is by limit comparison test. A sub n over B sub n. So limit and approach to positive infinity. 1 over square root of n plus 1 all over 1 over square root of n. So look, we have a fraction divided by another fraction. Then first fraction will keep that times the second fraction reciprocal, right? So this will be times that, right? Okay, so look. How do we take the limit this one? When n approaches to positive infinity, right? So we don't care about the constant term, right? So what do you get? One,
Yeah, it's just one.
okay. So all right, then this is some number, right? Some number. So some number. This is not telling us converges or diverges. Okay, we have to determine. All right. So look, this is what? Look, this is a very confusing. We are using limit comparison test. We check that. So if we get the number, which is, this is not A0, right? Then look, they said that we have to determine whether both the series is converges or diverges, okay? Then how do we do? Like a comparison test. How can we tell about this one? Someone said earlier. How do you say this one?
Oh, P series, because it's less than,
P
the P
series,
is less than
right?
one. Yeah.
P series, P equal to 1/2 is the last one. Is a converges or diverges?
Diverges.
Very good, diverges, right? So if B sub n diverges, we can conclude A sub n diverges, okay? By limit comparison test. A little bit confusing, huh? So we're gonna say that since the series B sub n diverges, so the series of A sub n also diverges by limit comparison test. All right. It's very confusing. We have to practice a lot. Okay. Okay. Second part. We have 2 to the n power plus 1 over 3 to the n power. Okay. Now we said that this is A sub n. We want to create B sub n. Does not have to be greater than A sub n. So what do you get this one? What do you think? How can we create?
Oh, just get rid of the one again.
Uh-huh. So we can say that that is a series of maybe 2 over 3 to the n power. We can say that. Or this one, we can say that's just a 2 to the n power over 3 to the n power. Yeah, same as. Okay, now we checked out whether the limit comparison test, we get the number or 0 or positive infinity. Okay, so let's say that. Check the limit when n approach to positive infinity, A sub n or B sub n. So take the limit when n approach to positive infinity, we have a 2 to the n plus 1 over 3n. Since we have experience, let us do 3 to the n power, right? Over 2 to the n power, right? Okay. Now we can simplify. When n approach to positive infinity, so we have a 2n plus 1 over 2 to the n, okay? So same concept with earlier. When n is approach to positive infinity, we have a 2 to the n, 2 to the n, because the constant is a too tiny number. So we do limit. When n approach to positive infinity, we have a 2 to the n power over 2 to the n. Then what again? It's 1. Thank you. Okay. So same reason, right? Okay. Now we're going to that. We're going to the b sub n because this is not equal to 0. Look, same reason. The number 1 type, right? Number 1 type. So we have to determine by ourselves. So let us do this. So how do you want to say this one, b sub n?
Like what series are we gonna use?
Yes,
Oh, geometric series?
geometry series is a converges or diverges?
Oh,
Converges.
Converges.
yeah.
Why?
Because it's less
Less
than
than
1.
1.
Excellent. R equal to 2/3 is less than 1. Okay. Since this is a converges, we can conclude the a sub n is a converges as well. Okay. So let's see. I'm sorry, b sub n. The series b sub n converges. So series of a sub n also converges by limit comparison test. Okay, so that's it. I don't think there is a, I cannot find the two problem is, this is 0, positive infinity. Most of the problem is going to the just number. All right, so summary, comparison test, we create the series very similar with a sub n, okay? And the direct comparison test, or we called just basic comparison test or just comparison test, okay? Then b sub n must be greater than a sub n, okay? We must check that, right? And then we compare basically, so b sub n series by what? Converging or diverging? So what kind of test, what kind of series were you using it, right? Then we conclude the smaller one series converges, the bigger one series converges. If smaller one, the series is diverges, then the bigger one series diverges, okay? Now, limit comparison test. We create same as the just comparison test, b sub n, but b sub n does not have to be bigger than a sub n series, okay? The limit comparison test, so we take the limit when n approach to positive infinity, then we divide from a sub n by b sub n, okay? Then since we have only couple example about this one, right? Okay, and if we divide, then we get a number is not equal to 0. Then we're going to B sub n. We determine whether diverges, converges by the test. Then we can conclude the A sub n also converges or diverges. Okay. All right. So there is one more problem about this one, but they do third time of the applied anything. Okay, so I want to stop here about the limit comparison test. Thank you.